The human element sets the stage for why human competence matters in LNG shipping, introducing this guide to certification, training, and mastery for modern LNG crews. This opening image of a vessel at sea signals the real world stakes. Well trained people are the single most important control in keeping crew, cargo, and the environment safe while operations grow more complex. The safe operation of LNG vessels depends on specialized expertise because LNG presents unique hazards like extreme cold and flammability. As shown by the thermometer and control room image, rigorous training reduces human error, embeds a strong safety culture, and ensures regulatory compliance so crews can prevent catastrophic incidents and protect both people and corporate reputation. The regulatory architecture for maritime safety rests on three pillars: the IMO, the STCW framework, and the IGF code. Together, they create a harmonized global baseline for seafarer qualification so that wherever a vessel sails, crews meet consistent standards. This slide's graphic highlights how international conventions unify requirements across the world's LNG fleet. At the heart of seafarer competence is the STCW Convention, which sets minimum international standards for training, certification, and watchkeeping. The illustration of layered roles reminds us that everyone from the master to ratings must hold appropriate certificates of competency, and that the STCW code provides the detailed technical specifications supporting those mandates. The IGF code specializes these global standards for ships using gas or other low flash point fuels, linking directly to STCW Regulation V3. This slide shows that STCW creates the Seafarer framework while the IGF code mandates ship-specific safety and training requirements, ensuring crew members have focused knowledge of fuel hazards, systems, and emergency procedures. Global minimums matter, but compliance happens through flag states and port state control. The flowchart on this slide shows how IMO standards are implemented by a vessel's flag administration and enforced when port inspectors verify certificates and operational procedures with potential detention for serious deficiencies, so international rules translate to onboard reality. Regulations set the floor, but reputable operators go beyond by embedding tougher company standards and industry best practices. The pyramid graphic illustrates how IMO rules underpin a company's safety management system and how organizations like STCW raise the bar, creating layered protections that keep crews familiar with specific vessels, systems, and higher competence expectations. Before specialized LNG certificates, every seafarer needs a core set of documents: a seaman's book or discharge book, a valid medical certificate, passport and visas, and flag state endorsement of their QOC. These items are the universal toolkit that proves identity, fitness for duty, and that a seafarer's credentials are accepted by the vessel's flag state. STCW basic safety training is the universal prerequisite for all seafarers, equipping crew with personal survival techniques, fire prevention and firefighting, elementary first aid, and personal safety and social responsibilities. The circular diagram emphasizes practical skills and awareness that form the foundation of safe behavior at sea and the shared baseline for emergency response. Beyond BST, the STCW Convention requires additional proficiency certificates for designated safety and medical duties, including survival craft and rescue boats, advanced firefighting, and medical first aid or care. This slide explains who needs each certificate and why these higher level skills are especially relevant given LNG's unique fire and rescue risks. The first step into LNG operations is basic IGF training for all personnel on LNG ships, providing a shared understanding of LNG properties, risks, general emergency procedures, and safe bunkering practices. The slide stresses that this foundational training ensures everyone on board, regardless of role, recognizes primary risks and basic safety protocols. Advanced training for IGF code ships divides into basic awareness for all personnel and an in-depth program for masters, chief mates, chief engineers, and those with immediate responsibility. The distinction is clear. The advanced course builds technical mastery of fuel systems, control systems, stability with cryogenic fuels, and detailed emergency strategies for shipboard leaders. When LNG is carried as cargo, crews need specialized, highly technical training beyond fuel as propulsion guidance. The longship illustration highlights cargo characteristics, containment systems like moss or membrane tanks, cargo handling protocols, gas detection, and emergency response, and notes that ship-to-ship transfers require specific familiarization with mooring, connections, and emergency disconnect procedures. The master holds ultimate responsibility for the vessel, its crew, cargo, and the marine environment, and must hold appropriate COC endorsements for liquefied gas tankers. This slide highlights the master's need for deep knowledge of cargo and fuel management, leadership and safety and incident response, and an educational foundation that typically includes advanced maritime qualifications. The chief engineer is the technical authority for cryogenic systems and overall engine room operation, requiring a chief engineer COC and LPG endorsements. This slide emphasizes specialized training in LNG propulsion, cryogenic pumps and compressors, emergency management through simulator training, and typically an educational background in marine or naval engineering. Navigational and engineering officers form the vessel's operational core, supporting watchkeeping, cargo operations, and machinery safety. They must hold appropriate COCs and complete basic plus advanced LNG training, with deck officers focused on cargo handling and tank operations, while engineers concentrate on operational parameters, routine maintenance, and troubleshooting of LNG systems. The electrotechnical officer maintains all electrical, electronic, and automation systems, requiring an ETO COC and in-depth training on instrumentation, control systems, gas detection calibration, and emergency shutdown systems. This slide also notes the growing importance of cybersecurity skills for protecting operational technology as vessels become more digitally integrated. Ratings and general crew provide vital hands-on support for watchkeeping, maintenance, and emergency response, and must complete basic safety training and vessel-specific familiarization. The image of crew working on deck reminds us that LNG-specific familiarization, correct PPE, and role-related task training are essential for safe day-to-day operations and emergency duties. High-fidelity cargo system simulators let crews practice routine operations and critical emergencies in a realistic, risk-free environment. The training bridge image illustrates how simulators sharpen decision-making, teamwork, and confidence by allowing repeated practice of complex scenarios like compressor failures, gas leaks, and emergency shutdowns before crews face these situations at sea. Simulators build a foundation, but competence is cemented through on-the-job training and regular emergency drills on the actual vessel. This slide explains how supervised hands on experience, structured checklists, periodic drills targeting cargo area fires and gas incidents, and organized debriefs ensure skills translate from the classroom and simulator to safe performance on board. Most maritime certificates follow a 5 year renewal cycle requiring continued sea service, medical fitness recheck, and refresher training. For LNG endorsements, renewal often demands proof of recent service on gas fueled vessels or completion of approved refresher courses. The message is clear. Strict adherence to renewal cycles prevents regulatory noncompliance and potential vessel detention. A valid certificate is only the starting point. Ongoing verification, audits, drills, meticulous record keeping, and continuous professional development maintain real competence. This slide outlines how performance assessments, internal SMS audits, and targeted CPD, including workshops and online courses, ensure crews keep pace with evolving technology and best practices in LNG operations. Global certification compliance faces three core challenges: variations in national implementation that create competence gaps, the rapid pace of technological change requiring updated skills, and human factors like language and cultural differences that complicate training and teamwork. Effective programs combine standardized technical training with crew resource management to bridge these hurdles. The return on rigorous competence is tangible: fewer operational incidents, a stronger proactive safety culture, and reliable regulatory compliance that protects the environment. This slide ties training and certification directly to reduced human error, empowered seafarers who challenge unsafe practices, and minimized risk of penalties, detentions, and fuel related environmental harm. Future proofing LNG competence means adapting the training blueprint to digital systems, AI diagnostics, um, remote monitoring, and stronger human machine interfaces. The final slide highlights emerging requirements like digital literacy, cybersecurity, and advanced interface management, and concludes that continuous improvement in training, simulation, and global standardization is essential for a safe, efficient LNG future.